Hello, good afternoon. Can you hear me? Hello?
Yes, sir, I can hear you.
Okay, thank you. Okay, so we can start our next session this afternoon. Let me show you my screen here. Just a minute. Okay, I'm gonna show you my art studio because we got some interesting examples down below here. Okay, we have done some codings in the morning, but maybe some of you have problems about the software installation. But that will be fine because we have one question from a student about how to install packages, because when you try to install packages like Tidyverse, it shows some tools that you need to install first, and then it breaks down, and you can't install that in packages successfully. So I suggest you to go to the when you start the RStudio, you should use System Manager to execute RStudio. Okay, because you need to be a system manager so that you can change some environment of the system when you try to install the packages. Okay, so if you can start executing RStudio using System Manager, then you can successfully install packages like RStudio. Okay, I think there is no problem about that. And then we probably need to go one step further. Just a minute, let me show you here. Okay, so we have seen some examples down here, and then we can move on to some more advanced codings. So now we have covered tables, and then we can move on to some other useful functions. So for example, like we can use when we try to subset our data, and we can use some special symbols. Okay, so for now here we have a data table, right? Okay, and then we have if we want to access specific column data, then probably sorry. Okay, now we need to subsetting table. Sorry, subsetting table data. So for example, like my table 1, if you want to see the first column, then you should use a square bracket here. Okay, and inside the square bracket, you should type 1. Okay, then you can see the down below here, you see this is the first column data. Okay, however, if you wanna see the data frame, okay, so for example, like data frame here, If we want to access the data frame, we have to use some special character like my df1. Okay, then you can press $sign. Okay, of course you can also use $sign table. But if you want to access specific columns in data frame, $sign is a very standard way to access specific columns. Okay, so for example, if you want to access X column in my data frame, okay, so we have the first column called X, okay, and of course you can also use my tip1 and $sign, no problem. Okay, you can also access X column. Okay, so that's very straightforward to access specific column. But if you want to access the specific column by specifying dimensions, yeah, you can do that too, no problem. So for example, like if you want to access the second column here, let me see. We should access column, second column, yeah. Okay, so the first number is the rows, the second number is column. So I specify the second column for all rows in my data. So I can just use this to access my column data. Okay, so that's very straightforward. Okay, then we can also do some calculations in our table data. So for example, like just do some calculations here. Table. Okay, so this is very simple data here. 1, 2, 3, and cost equal to yeah, I just gave numbers randomly. Okay, and then total cost will be and multiplied by cost. Okay, so that will be very straightforward to create a table like this. N is the number of items and cost, and then total cost. Okay, it's very straightforward. Okay, then you can create a table like this. Okay, so that is a short conclusion for the table data set. Then we can move on to the next one. Maybe we can do more like data arrangement. Okay, so for now we can just take some extra data set. For example, we're gonna import data set. We have a data set called CO2. Okay, so when you type CO2, it will show this screen specifying the data set name. Okay, so this data set has been loaded up automatically when you install the library. So we have CO2 data set here. Okay, and let's see what's the data here. Okay, so if we go to the right hand side here, let's check the data set. Okay, so you can see the data set here. We got CO2, and we got the plant type, treatment, CONC. I'm not really sure about this, but it should be some measurement based on the plant treatment. Okay, and uptake, whatever. Okay, so this is the CO2 data. Okay, now we have how many data we have? Let's see, we do have 84 observations with 5 variables. So this is our data set. Okay. And then we can do take a look at the structure of CO2. Okay. Okay. So this is a structure of our data set. We got the plant, the type of the type of variable is order factors, okay, with 12 levels, QN1, QN2, QN3, etc. And we also have type, we have treatment, we have conc, and we have uptake, okay. So those are the data variables in our data set, okay. So what if we convert, okay, so maybe we can check the class of the data set. Okay. Okay, so now you can see the class of this data set. We have some special information, okay. This shows NFN group data, NF group data, and the group data, and the data frame, okay. What we can understand is the group data in the third element, and the fourth element is data frame. Okay, we just want to make sure what kind of data we have here. Okay, so this data actually is a data frame, no problem. Okay, so maybe we can use a different function, glimpse, to check the data set. Okay, so this is another function to have a very brief understanding of the data set here. Okay, so now you can see if we just use glimpse, it shows number of rows and number of columns. Okay, and of course it will show the data type. So the first variable plant is order factor data type. Okay, the second variable type is a factor variable. Okay, and the third column is a factor variable. Okay, so basically this is a data frame, but the variable type for each column has been given. Okay, so these three functions are important and maybe useful to you if you wanna, check the information inside the data set. Okay, so now let's convert the data. Let's just convert data to table. Okay, convert data frame to table. Yeah, we have just covered that before. So now we know how to convert data to table, right? So we're gonna use underscore table. Okay, this can convert our data to table immediately. So let's see what happened. Okay. So now you can see this data set has been converted as a table. We have 84 rows by 5 columns. Okay, we have plant type, treatment, conc, and uptake. Okay, and we can convert this to table and give a name to this variable. So we go to CO2 tip. Okay, so this is what we got here. Okay. Now we are talking more about more important functions. So in the foreign, you should be put more. You should be more focused on these issues. Sorry. 喂，开门是在哪里开门？啊，OK。Sorry, just a minute. Okay, sorry. Now we can use a function called select. Okay, so select is very important because we can use select specific columns for analysis. Okay, it's very simple because we can just use function select, and then we just type CO2 tip. Okay. Suppose we want to select column 1, 2, 3. Okay. And 5. Okay. So if we use select and followed by the database and data variable and then followed by the column we want to select, then we'll get the result. So for this example, we have print, type, treatment, and uptake. Okay, which is column 1, 2, 3, and 5. Okay. But usually we can use different ways to express the data set because we're gonna use a pipeline. Okay. To save some typings. Pipeline to save codings. So for example, like we can use this one. Okay, so let me jump back to the line 52. Okay, and then we can use this pipeline. So what is pipeline? Pipeline in R is percentage greater followed by percentage. Okay. And the fast key, yeah, you can use fast key. Control Shift N. Okay. Okay, now we have Control Shift N to show the pipeline. Yeah, you can memorize the fast key because it can save you a lot of time typing. So it'll be more faster. It'll be faster for you to do that. Okay. So what it does mean here is just to pipe the data we created on the left-hand side and pipe into the right-hand side for data analysis. So for example, this case, we have CO2, okay, we converted it to table data, and then we can just use select, okay? And then we can just use 1, 2, 3, 5. Okay. Then we call this select. Okay. Okay, so let's check the result. Okay, now you can see if we use pipelines, we can just omit the variables we need to type here. Okay, originally the variable we have here is the dot. Okay, and followed by the columns we need to select. But in this case, the default value is dot, and the dot is CO2. Okay, the dot is CO2. It's very similar to this one. Okay, for example, let me just repeat it. Let me just show you here. Okay, so this is our original data set, CO2 TIB. Okay, and then we can also use this to select the 4 columns here. Yeah, of course, you can also use this way, CO2 pipeline as TIBBRE. Okay, and then select 1, 2, 3, 5. Okay, so even if you want to make your codings to be shorter, and you can use this way. Okay, CO2 is our original data set, and then piped in as table, and then piped in, and we select 1, 2, 3, 4, 5 columns directly. Okay, so this is how pipeline is working in R. It really can save you a lot of time in the codings. Okay, it will be more efficient. Any problem about this? Okay, so that's about the pipeline here. So now we know how to use select. Okay, it's very important here. Okay, select, and then we also have some functions. We have a function called filter. Filter. Filter means we can filter specific rows. Okay, based on filter data based on condition. Okay, so for example, like we have some data here. So for example, like we want to select our data. We have CO2. We have CO2 selected. And then we need to filter data here. Okay, need a filter. Okay, so filter, the first argument should be the database, right? But since we are using pipeline, we're assuming that the default variable is dot, and the dot actually represents the data we have on the left hand side, CO2 TIB underscore selected. Okay, so dot equals to this. Okay, but usually we don't need to put dot here. Okay, we just put the condition we need to specify. So in this case, we can just type some numbers. So for example, like we need to filter our data with the uptake greater than 16. Okay, greater than 16. How about that? Okay, so let's see what we have. Okay, now you can see the result here. The original data set is 84 by 4, but after we filter our data, then you can see the number of rows is 66 by 4, and the uptake here is all values in the uptake here are greater than 16. Okay, so filter is a very useful function to filter our data. Okay. Okay, so that's about the filter. Very great function. And then I'm gonna introduce another important function we call grouping. Group data with group by. Okay, so you can see what it means here by grouping. So let's see our data here. To table selected, and we going to group our data by plant. How about that? Okay, group by, and we can just type plant. Okay, so let's see what we got here. Okay, so you can see here we have a result like this. We still have the same size of data, which is 84 by 4. However, now you can see one extra line showing the groups, showing that we have 12 groups based on the plant. Okay, we have QN1, QN2, QN3 until QN12. Okay, so this data has been created based on the group data. Okay, so suppose we just save the data as group data. CO2 TIB group. Okay, how about that? Okay, we save it as group data. Okay, so let's see this type group. Based on this data, we didn't see any difference from the ungrouped data, right? Okay, we can see the QN. Okay, there are many different types of plants here. Okay, so basically there are 12 different types of plant. But if you want to do some calculations based on the plant, then it's important. Okay, so for example, like if we want to calculate the mean value of the uptake, okay, and the standard deviation of the uptake, then we can just use the group data to help us to do that. Okay, so if that's the case, then we can just let me just delete this. Okay, so for example, like we can just move on to summarize. Okay, so summarize is a function to calculate the group data. So we can just use mean up equals to mean uptake. Okay, and then we can calculate the standard up equals to standard deviation uptake. Okay, so let's run it. So let's say CO2. Yeah, we should be careful because we have replaced original data, CO2 tip underscore group, by the summarized data. Okay, so now you can see CO2 tip underscore group has been replaced by the summary data for each plant, okay, you can see we have mean value for uptake and standard deviation for uptake, okay, based on each group. So the data will be 12 by 3, okay? So that's what we got here. Okay, so that's about the summarized data. But remember, when you want to do further analysis on the group data, you should sometimes you should ungroup the data if you don't want to do the calculation based on group, okay? So you should ungroup it. So usually when we are done with this, we like to add ungroup here. Okay. It does. You won't see changes here because the data here is the summary data based on group. So when we ungroup it, you won't see any changes here. Okay, but if we are just using data for grouping, and then we need to do some special calculations specific to each rows or specific to each column, not specific to group calculation. So if that's the case, then we have to use ungroup. Okay, ungroup means to unlock the grouping status, meaning that we don't need to calculate the data based on a group, okay? But if you want to calculate your data based on a group, then you have to use group data. Okay, so that's a very important thing we need to know. Okay, so for example, like sometimes we need to calculate our data based on our results, then we can use mutate. Okay, so mutate is another function, okay, to calculate, mutate to calculate new columns or data or variables. Okay. So for example, like we're gonna use, okay, we still use the same data, CO2 T group. How about that? Okay, so be careful, this data is summarized data. Okay, remember? This data is summarized data based on the mean value of uptake and the standard deviation of uptake. Okay. So if that's the case, then we have to use the mutate here. Mutate here. Of course, the default value is dot here and followed by a comma, but now we don't need it because we are using pipeline and we can calculate the new value we call CV. How about that? Equals to standard up divided by mean up, okay, and multiplied by 100. How about that? Okay, so that means we are gonna use mutate to calculate new columns of variables here. Okay, then you'll see a new column called the CV has been generated. Okay, and this new column is generated based on the means of up and the standard deviation of up. Okay, so you can do any calculation like using mutate. And this is a great function. All those functions are based on package D prior. So dpri is very important package in our data manipulation. Okay. And I want to introduce a very useful function called arrange. Arrange. Okay, arrange functions is a function to reorder. Okay, reorder the data here. Okay. So, for example, like let's say we're gonna call this data a new name. Called mutate. How about that? Okay. Well, we call this new column, the data with new columns as CO2 TIB underscore mutate, so that we can use it again here. Okay, so arrange here is to reorder the data. Okay, so we can use arrange CO2 TIB mutate. Okay, and then we can also use arrange, and now we just focus on CV. How about that? Which means we like to reorder the CV from the smallest to the largest value. So now you can see here the result here. It shows CV reorder on the smallest value to the largest value. Okay. If you want to see the descending order, then you can just use descending. I believe it should be this DESC. Okay, if you use descending here, DESC, followed by the CV, then you can see the CV is reordered from the largest to the smallest. Okay, so that's about this descending, the arrange function. So all those functions are important. Okay, so now we have some interesting functions here. Okay, so all those functions in the above are trying to manipulate or do some reorder, rearrange, okay, or to create new columns, whatever. Okay, so totally based on the data itself. Okay, but in the following here, we are trying to restructure the data. Okay, so what does it mean by restructure? Restructure means sometimes we need to reshape the data. Most of the time we have we call the data set as a tidy data set. So what does tidy data set mean here? Tidy means clean, right? So put it in another word, we call tidy data set means clean data. So what does clean data mean? It means a long data set. Okay, so if a data set is a long data set, then we call this as a tidy data set. Okay, so for example, like we have stock prices, right? For example, like we have 10 stocks and we have the historical price for these 10 stocks in the last 10 years. Okay, so how are we gonna represent our data set for this information? First of all, we have date time, right? For the last 10 years. So for example, like our data set is daily data. Okay, and for each day, for each daily data, we have 10 stocks closing prices. Okay, So how are you gonna arrange the data set? Okay, there are two ways to do that. Okay, one is long wide data set. It's very traditional in finance or in Excel. You can see this kind of data set in Excel. First column is time series. Okay, for example, like from January 1st, January 2nd, January 3rd, etc. Okay, and the second column will be the first stock closing price for each day. Okay, and the third column, okay, just imagine that you are in Excel. And the third column will be the second stock price name, and the second column will include all closing prices for each day, for second column, so for the second stock price. Okay, and we can arrange this data set in this format. Okay, if we have 100 stocks, then the number of columns will be at least 101. Okay, including the first column is date series, right? But what if we have 1,000 stocks? If we put 1,000 closing stock prices for the last 10 years in Excel, can you imagine what it would be like? Then this data set will be a very wide data, right? Even though we have a very long time series, but based on each column, we have the closing price for each stock. So we have a wide data set. Okay? So that will be very easy to understand. But what about the long data set? Yeah, maybe you can just imagine that. We can just put all closing price for the first stock in the first column and in the second column. Okay, so for the first column we still have time series from January 1, January 2, January 1, January 2nd, January 3rd, for example, and the second column will be the closing price for the first stock. But we need to complete all closing prices for the first stock until the end, right? And then we just put the second stock closing price for the last 10 years. And after that, we just fill the third stock closing price for the last 10 years. And then what it means is that we can just place the closing price for one stock on top of the other. Then we'll have a long data set. Okay, maybe you don't quite understand that. I will give you an exercise about that. We'll do that later, but first of all, at least I just need you to have a very basic concept about that. Okay, so maybe we can try some examples here. Okay. So let's see, we're gonna use some fake data. Okay. So for example, now we have a patient data, and this example is based on textbook. So very simple and very straightforward. So now let me just type it. Patient equals to C. We got the patient A, patient B, and patient C. Okay. And then we have some information, for example, like month 0, 21, 17, the 29. Okay. Month 1. And this is month 3, 20, 21, and 27. A month. Sorry about that. Just give me some time to type the data. 21, 22, and 23. Okay. So that's what we have here. Okay. It's a table data set, and let's see patient data. Okay. So this is what we got here. So this is very similar to the white data. Okay. So now we need to convert our data. So what we're gonna use is a function called gather. Okay. So we need to use a function called gather. Gather is the function to rearrange the data structure to long data format. Okay. So how are we gonna use this? We can just use this as a patient data, then we just pipe in together. Okay. And there are two important parameters that we need to feed. The first one is about the key. Okay. Equals to month. Okay, the month is the column name we specify, which means we need to put month 0, month 3, and month 6 in one column. Okay, so this is what gather means here. Okay, and then we need to create a second column called BNI. Okay, the BNI is the value corresponding to each month. So we call BNI. Okay, and this should be the value. Okay, so the key parameter here is value equals to BMI. Okay. Okay. So so it seems that we missed one parameter here. We should put negative patient. Okay. Okay, so that will be correct. Okay, we need to put a negative patient here. Otherwise, the result will be like this. The patient will be mixed with our data here. Okay, so we just negative patient, then the data will be focused on a month and a BNI, and then for patient column, it will feed the corresponding values to month and BNI value. Okay, it will feed the patient name to the corresponding month and BNI value. Okay, so now you can see we have a patient, month, and BNI. Okay, so now we turn the data into a tidy data. Okay, so this is what we have done here. Okay. Okay, then we can do some practice. But before do the practice, we can also let me just finish the another important function. We need to just a minute. Okay, yeah, corresponding to the gather function, okay, gather is a function to rearrange the data structure to long data format. And on the contrary, we have a function called spread. It's a function to convert data to wide format. Okay, so these two functions are useful. And for example, like we need to convert data back to the wide format. So let's see. Okay, so let me just save the file to patient tidy. About that. Okay. Now we have a data set called patient tidy, right? So this is a long format. Now we need to convert the data back to wide format. So we have patient tidy, then we need to use spread. Okay, spread. Then we also have a key value equals to month. Okay, and we also have a value equal to BMI. Okay. Okay, now you can see we have converted data back to wide format here. Okay, so it's very useful. And another interesting function not mentioned in the textbook is the dcast. Okay. Uh, okay, so that's the function is based on the different. Okay, so let's find the dcast function, and because maybe we need to use the dcast function to do some analysis. So let me see. Okay, so just a minute. Let me just give up this function for the moment because I need to complete the session, the less important function about the plotting. Okay, so let's see about the plotting. Okay, so now we're moving to the second session about the plotting, which is ggplot2. This is a very useful function for plotting. And before we start working on this, maybe we can take a 10-minute break and we'll come back later. Okay, so see you later. Take a break here.
Okay, sir. Thank you.
See you later.
Hello? I'm sorry, sir. I think you haven't unmuted your microphone.
张老师没声音哦。
Okay, is it okay for now?
Yes,
Hello?
sir. Yes, sir.
Okay, thank you.
Yes, sir.
Okay, so now we are, okay, so let me start from the ggplot here. Okay, so we have iris data set. So here we are gonna use ggplot function called ggplot. Okay, so inside the ggplot, we have originally we should have a data here, but since we are using pipeline, we can omit the dot here, and then we can use AES. AES means static setting. Okay, static setting. That means we have set up X, and we also have set up Y variable, X variable, Y variable. Okay, and then we have the following setup, and then it just complete half of the plotting. Why we call half? Because is static setting is just a setting for a blank sheet. Okay, for blank sheet, and inside the blank, on the blank sheet, we need to pen something on the blank sheet. Okay, so let's see what happens. We just execute this line of code. Okay, so now you can see on the bottom of your right hand side, you can see there's a plotting area. But now you can see X and Y, but nothing in there, right? So this is a blank sheet. We can also use zoom, okay, to show you the whole picture. We have X and Y, but we don't see anything inside here. Okay, so this is a blank sheet. And based on the blank sheet, we need to pen something more. Okay, so for example, if we want to draw a line or we want to plot points on the figure, it depends on you. So then we need to, since we need to add something to the figure, we have to use plus sign. Okay, be careful, this time we should use plus sign instead of pipeline. Okay, in the ggplot. So plus sign, after the plus sign, we need to specify something on the figure. For example, like we need to specify geom point. How about that? Okay. So we specify geom point means geom means geometric. Okay, geometry, and point, yeah, just means point. So let's see what happened here. Okay, then you can see the plotting here. Okay, so we can see a lot of plotting here, and you can see the plotting has been created. Okay, so basically it's very straightforward. Okay, so what if we need to differentiate those points based on species? Because we know those points are just based on sepal width and sepal length, right? But we need to specify those points based on species. So that means we can add different colors to the points. So if that's the case, then we can add some more commands in our aesthetic here. So how about this? Let's add some color. How about that? Okay. Color equals to species. Okay. Then we can just do it again. Okay, then it looks better now. You can see we have points based on the species. We have 3 different colors, okay, although it's not very clear here, but you can see Setosa is about the red or orange, I'm not sure about that. Versicolor is green and the Virginica is blue, okay. Yeah, of course you can change the size of the point, okay, and in fact you can change anything you like to see on the figure on the plotting, okay, no problem about that. But now since this is not our focus in this course, so I'm just gonna give you a very simple introduction to the function of plotting, okay. So maybe we can add some special effect. So for example, like we have a function called theme BW, okay? Let's see what happened here. Oh, sorry, we need to need a function in the end. Okay, so theme BW means the background of the figure, and BW means black and white. So we can make our plotting to be clearer than before. Okay, so that's about the plotting in black and white. Okay, and of course, if you like to see different shapes based on species, we can also change color. We can replace color to shape. Okay, so that's how we can change the species, change the plotting based on species. Okay, but since the plotting are all in black, we cannot see the species very clearly. So it's not very good to. So maybe we can. Let's see if it works. Okay, so if we add more, for example, like we like to see the colors and the shapes for each species, then we can add the shape and the color to our setting. Okay, so this is a very simple example. Sometimes we like to see species in different figures. So if that's the case, then we can use facet wrap. Okay. So for example, like if we add one more line about facet wrap. Okay. And we're gonna use species. Okay. Okay, so this is what we have here. We like to see the scatter plot of sepal length and sepal width based on different species. Then we can have a result like this. So the facet wrap is a function to wrap our data by the categories. Okay, by categories, for example, like this. Okay, so this is a very simple function for plotting. Okay, so like I mentioned, we have done some interesting functions. Okay, so then we need to we need to know more about the some useful functions. Okay, So let's see what we're gonna do here is okay. So we mentioned one important package, which is about the per. Okay. So what does per package doing? What is package per doing here? Basically, per package is very similar to the mapping package, and it can save us a lot of time in looping. Okay, so when we try to do something about looping, for example, like we like to repeat the execution for many times, then we can use per to do that. Okay, so for example, I'm gonna use some functions here. So let's see, let's just create some numbers here. List of numeric. Okay, so we have a new function called list. Let me finish this first. Okay, so what I'm trying to do here is to create some random numbers. Okay, so let me just explain to you. Okay, so first of all, I just specified a function called setSeed. Okay, so setSeed is a useful function to specify the algorithm of random number generator. So if I specify specific number, for example, like 1, 2, 3, 4, and you also specify seed number 1, 2, 3, 4, then my generated random numbers will be the same as your random generated numbers. Okay, so for example, like in my case, if I set my seed to be 1, 2, 3, 4, 1, 2, 3, 4 is just a number. It's just a random number. You can type any number you like. Okay, you can type 999, 4321, whatever. Okay, but only if my seed number is the same as your seed number, then my randomly generated numbers will be the same as yours. Okay, otherwise my random generated numbers will be different from yours. Okay, so that's one way to check our results. So if that's the case, then let me create three variables. The variables A is a random normal distribution values. Okay. So if you want to know the function a random normal function, we can just type a question mark. You can see down below here we have a console here. You just type question mark and you type RNOM. Okay, and then you press enter. Oh, oh, sorry, typo. RNORN. Okay. Okay, when you type the RNORN, you can see we have D norm. Sorry. We have D norm, we have P norm, we have Q norm, we have R norm. Okay. Of course, P known, D known is D for density, P is for probability, Q is for quantile, and R is for random variables. Okay, so you can see, but here we just using R norm, means we are trying to generate a normally distributed random variables, and the mean value and standard value is set to be 0 and 1, which means these random variables are generated from the standardized normal distribution. Okay, of course you can specify different values to mean the standard deviation, but here we don't, since we didn't specify any values to mean the standard deviation, so we are using standardized normal distribution. Okay, and n means the number of observations generated by the function. Okay, so here we are, we have a, which is 5 values of random normal distribution function, and B and C. Okay, so what about the list? List is just a list containing many variables inside the list. But list is very useful because we can put different dimensions of variables in the list. For example, a variable contains 5 variables, 5 values inside. B variables contains 9 values. C contains 10 values. We don't require all of them to have the same dimensions. Okay, you can just imagine a list to be a big closet, and inside the closet we have many drawers. Okay, we have drawers, and inside the drawers you can put anything you like. Okay, so basically a list is like a big closet, and inside the closet we have many drawers. Okay, so when you pull one drawers, you will see different variables inside the drawer. Okay, so let's see what we have here. Okay, so now I got the random variables from my computer, and of course you can also check to see if you have the same values as mine, because I set C to be 1, 2, 3, 4, and if you are setting the same values as mine, you should have the same values I have here. So for example, A, we have 5 values here. Right? Do you have the same values as mine?
No, I got the different values.
You got different values
Yeah.
already? I thought we should have the same values. Okay. I'll try to figure out why, but okay. I'll try to figure out why we have different values. Okay, but then never mind. If you don't have the same values as mine, that's okay. Well, I'll try to think about that. But this is not very important here, because we are trying to explain the functions based on the package per. Okay, so what we're gonna do next is we like to do some calculations based on 3 variables, A, B, and C. Okay. So for example, like we need to check the length of the 3 variables, and it should return the length of the variables, okay, for 3 variables. Okay, so if that's the case, then probably we need to write a looping function. So in terms of the looping function in R, maybe we can just write a function here. So for example, like let me see. Maybe this is not a good example, but let me just introduce you a special function. Okay, we call the SQL alone, and we can just show you the list of numeric. Okay. Okay, so this is a very special function. Maybe this is not a good example, but you can just take it as a particular case. Okay, you don't really need to memorize the function here, but you just, all you have to know is just to know the structure of looping in R. So sequential alone will return the number of elements within the list. Okay, so you can see there are 3 elements in the list. Like I mentioned, there are 3 drawers in the big closet of this list. So it should return 1, 2, 3. So it shows sequential order of the element. So if we want to check the element, the length of the element within the list, then we can use this. Okay, so if we want to use looping in R, okay, we're gonna use for. Okay, and then we can just write I in seq long, then with this of numeric. Okay, then we can okay, so let me just create element. No, this is just a good idea. Okay. Okay, so let me just follow the example. List and 2, 3. Okay, so I'm trying to create the empty vector. Okay, and vector contains the 3 elements. So I just specify the length to be 3, and the type of the vector is specified to be list. But I don't think it's a good way to represent our data. So I'm trying to okay, so we just follow the codings here. So let's see, element and okay, there'll be length, list of numeric. Okay. So now we just using a looping function to find the length of the element here. Maybe this is not a good example because some commands seems to be too complicated to you. But don't worry. Yeah, this is a very simple, very straightforward example. We will not use this example again because what we are trying to do is using some other function to replace the looping. So down below here, a looping example to compute the length of each element inside the list. Okay. So here we are creating a looping function to calculate length of each element inside the list. Okay. So we can run the looping here. Let's run it. Okay. And we can check the detail of the element n. Okay, then we see the result here. We see 5, 9, and 10. Okay, so 5, 9, and 10 corresponds to the number of values for each variable. Okay, so this is what we are doing here. Okay, but if we have better functions instead of using looping, then it can save us a lot of time writing the looping codings like this, because it's a very tedious way to run the looping. Okay, so here we're gonna introduce a useful function we call the map. So what does map doing is to iterate functions on the element. Okay, so on each of the element. Okay, so what mapping is doing is to iterate functions on each of the element. Okay, so it's very useful. So for example, like we have a function called length, and for example, like we have a variable a, right? Just a minute. We have a list of numeric, and we have a, right? Okay, we have variable a, and what is it inside here? Okay, we have variable a. A variable contains 5 random variables, 1, 2, 3, 4, 5, and we like to know the length of variable a. So we're gonna use a function called length. Okay, we're gonna use the function length. Okay, the length will return a value showing the length of the variable a, and it is equal to 5. So length is a very useful function. So what if we can just use map to iterate length function on each of the element. Okay, so if that is working, then we can save a lot of time doing looping, right? So now we can use map. What about this? We can use map list of numeric, okay, and then we can just use length. Okay, what about this? Okay, then we get the results immediately. We get the length of A, which is 5, length of B, which is 9, and length of C, which is 10. So actually, we don't need to write looping anymore. We can just use map, and it can saves us a lot of time here. Okay. So mapping is a very useful function. So if you want to know more about map, you can just type map here. And it's inside the perv library. Yeah, you can see here we have a lot of mapping functions. We have map, okay. We have map to character, map to numeric, map to data frame. We also have other map function like map DBL, map CHR, which means we'll return a vector, character vector, int return integer, vector integers, etc. Okay. So a very useful function here. So for example, like we can also use map integer. Okay. So let's see what happens here. Okay, so if we use map integer, then you can see the result is like this. Okay. So very simple, very straightforward example. And we can also use map df. So it will return table data showing A, B, and C with a specific number of lengths. Okay. So that's about the map. Okay, we have many different applications in map. You can also use the calculation to do the mapping. Okay. Okay, so that's about the mapping here. Okay, so here are some functions which are important in our data manipulation. So I have an exercise for you to do. You can go to the file here. Okay, you can go to the directory, file directory here. I have a closing stock prices in 2019 for Taiwan stocks. Okay, So this file is a text file. I need you to import the data, okay, and try to arrange the data, which means I'm asking you to change the data to wide format. The original data format is long format. I'm asking you to change the data to wide format. So let me just show you the question here. Okay, just a minute. Just the practice. Okay. So the exercise. Just a minute. Question 1. You need to import data 2019 daily closing 1.txt into our studio and rename column to ID and date close. Okay, I should put it in different file. Let me create a new file. Okay, so that will be clear. Okay. So question 1, let me show you the data set. Where's the data set here? Sorry, should be here. Okay, so let me open the file. Okay, now you can see the data inside the 2019 daily closing 1.txt. Yeah, we have some Chinese characters here, but don't worry, I'll tell you what it exactly means here. The first column here, we have stock ID. Okay, so it starts from 1101, 1102, 1103. The second column is the name for stocks, short name for the stock. It follows by the Chinese name, the first row, the second row, the third row. Okay, and the third column is the closing time. We have year, month, and day. Okay, and the last column, the Chinese character, Chinese word showing that it's closing price in dollar. Okay, so you can see the closing price for the first stock 1101 is 30.6778. Okay, and the second stock, the closing price is 31.7778. Okay, so etc. So obviously this data is a long data set, right? A very, very long data set. But this just contains 1 year data. So you need to convert the data into wide data set. Okay? Remember how we can convert the data into wide data set? And if we are converting the data into wide data set, we only need, for example, the first column is the date, right? And the second column follows by the first stock closing price. The third column is the the second stock closing price, etc. Okay, so we only need stock ID, time series, which is year, month, and day, and the closing price. Okay, we don't need a name here, but of course, my question also asks you to change the data, rename the column to ID name and date. Okay, so you can just you can just use the I'll give you some hint here. Maybe you can think about it. We can use read table to import data. Okay. Okay. So that's one. The first step, okay, the first step is to import data, to use read.table to import data. Okay, and then second step is to change the column name. How to change the column name? It's very easy. We can just use column name function. Yeah, column names is a function to change the column name. So how to use column name function to change column name? So for example, like let's just find help here. Okay, column names. There's some example here. You can just change the column names here by specifying the name. Okay, so for example, in this case, let me show you here. Yeah, we have some examples in the beginning here, right? Yeah, we have my DF, right? My table, my DF. How about this? My DF, okay. So for example, here we have my DF. Okay, so we have first column we call X, the second column we call Y, right? So how to change column name here? Let's see. Change the name to be XX and YY. How about that? Okay, then we can just type YDF1. Okay, so you can change the column name to be XX and YY. So it's very easy to do that. Okay. Is it okay for you? Okay, so let's take a break first, and then we may think about the problem, or maybe we can move on to the next session, but we take a break first. Okay?